Okay, quick little sound check. Sound check sounds good, as always. So, welcome back here on this Friday night. We're going to be doing some more Atari 5200 programming, if the cat will allow me to. And I trust that in the long term, she will. You want up here, sweetie? No, you don't. Okay. So, we're back here for another fun lesson in Atari 5200 programming. At least I hope everyone's having fun. So I do want to mention right now that there will not be a stream for this next week. I have a Veterans Day commitment, so we won't be seeing this next week. But hopefully the week after that, we'll be able to come back and continue with our little fun project here. So before we go too much farther, let's go ahead and take a look at what we've got, where we got to last week. And you can see here, I've had this running for a while. You know, I've had this running for about the last 15 minutes while I prep for this stream, just to make sure it doesn't crash or anything. So we got our little game. We got our spaceship here on the bottom of the screen. We can move, we can shoot. We got enemies just kind of moving back and forth, raining bombs down on us. Although at the moment, those bombs don't really do anything. But ours do. So we can shoot the enemies, they will die, and then get respawned with another one, moving very fast. The speed, I believe, is random. Ooh, hit that one. And it even awards points. If you see that, I'm getting 100 points every time I pop one of these ships. Look at that. Look at that. Look at that. Bam, bam. And these guys just keep coming, and this is all they do. They come in at random speeds. They never move vertically, and they just drop bombs continuously. Now, you notice, too, that the bombs are all white. So I do remember last week we enabled fifth player mode, which allows you to give the missiles a distinct color, independent of the player objects. But it is the same color for all four missiles. So you don't get to come up with four new colors. You just get one new color that is applied to all four missiles. And I don't know if I really talked about this last week, but the reason they call this fifth player mode is because you can take all four missiles and put them together side by side with this new color and effectively get a new player object, a new 8-pixel wide fifth player object, which I have used in a couple of my projects. For example, Robin Banks, my most recent project, I use fifth player mode to make the red cop. The red cop is actually the four missile objects all just stuck together. But here we're leaving the missiles as independent objects. So all fifth player mode really does is allows you to set an independent color for the four missiles. But this is where we left off last week. And I wasn't really sure where to go from here. I've been thinking about it all day. You know what? I think I'm still not entirely sure. But, I think maybe the thing to do might be to start off by adding hit detection for the player. Because right now, these missiles that are being dropped on the player don't really do anything. So maybe we'll start with that, and we'll add the ability for the player to get killed by the missiles. How does that sound? That sounds like a fun thing to try. So let's go ahead and kill the emulator here. All right, we'll go back to the code. Now, so if we're going to do this, we need to find a place to put it. So let's go back down here where we've been kind of shoving all the game logic. And something I probably should mention is that this is not necessarily the best structure for this code. I'm kind of doing it this way just for the sake of expediency and keeping the stream rather simple. But as your project gets bigger, you need to be more and more concerned with structure and how you organize things and stuff like that, which is something I'm not really touching on in this project. But you'll know the problems when you get to them, when you realize this is a mess. I need to move things around and refactor things. But let's go here. So here, let's see, move player shot. Okay, here we go. So here's where we were actually doing a lot of logic. We wrote this process enemy subroutine, and it looks like we passed the enemy number in the Y register because we load Y0, process enemy, Y1, process enemy, Y2, process enemy. So process enemy seems to do the bulk of the work. And then here we load missile 0 to player collision. So M0PL, this is missile 0 to player collision. So this is what we're checking for collision between the player shot and our enemies. But now we kind of want to do the opposite. We want to check collisions between the missiles 1, 2, and 3, which are the enemy shots, and player 0, which is the player that we control. So I think the first thing we're going to do is to check that out. So, okay, so here's the end of our game logic, effectively. So after this label here, it says no hit enemy 3, we store a value to hit clear. So this is the collision detection reset register. So at this point, we're done. So we store hit clear to reset the collision detection. So the next frame, we get a fresh read. And then we jump back to the game loop to start the next frame. So the player hit detection, we're going to put in here before we clear it, obviously, because if we clear it, there won't be anything there. So we need to know if any of missiles 1, 2, and 3 hit player 0. Now, in this case, we don't really care which missile does the hitting. We just want to know if any of those 3 did it. So the easiest way to do this is to load the missile 1 to player collision register. And then bitwise OR it with the other 2. So we're just going to collect all the bits into the accumulator. So we'll OR it with missile 2 player to collision. Then we'll OR it with missile 3 to player collision. So now in the accumulator we have a combined amalgamation of all of the missile to player hits from missiles 1, 2, and 3. Now we're interested in collisions with player 0, which is the least significant bit. So then we will AND the result of all of this with 1. And if that equals 0, then the player was not hit. So we'll branch to no player hit, which we'll put right in front of hit clear before we go to the next frame. So if we get past this branch without branching, then the player was just hit by a missile. So I'm going to do here is I'm going to, you know what we're going to do here? We're going to do a jump star. So jump star, which I haven't used in a while, so I'll refresh everyone's memory of what that does. And this may just be a DASM thing. I don't know if other assemblers allow this or not, or maybe they have a different notation for it. I'm not sure. But in DASM, jump star jumps back to the current location. So effectively, it puts the processor into an infinite loop. So it's just going to lock the system. So this way we can see that the player was hit, because when the player gets hit, everything's just going to immediately freeze. It's just going to lock the whole system. So this is how we're going to confirm that our code is working. So let's check this out. I have a feeling it's going to happen pretty quickly because these enemies, the enemy fire is pretty dense here. All right, so here we go. Let's get hit. Oh, look at that. System freezes. So we now have collision detection on the player, which is great. So now we need to do something with it. Now, the question here is, what do we do with it? So how do we want this game to work? Does the player die in one hit? Does the player have a health gauge or shields or something funny like that? I don't know. We need to make decisions about that. But whatever those decisions are, this is where that happens. So I think what I'm going to do, let's see. What do we want to do here? Well, the cat has input. What do you think we should do here? Okay, I'm going to listen to her. See, she says we should just make the player die. So let's go ahead and do that. So, how are we going to make the player die? There's a couple different ways you can do this. So, I would like to have actually a little death animation here. You know, something something we can play. You know, something that will, some sort of visual effect of the player dying. So there are a few different ways you can do this. Now, one way is to set some sort of an indicator somewhere that indicates that the player is currently blowing up. And then have the game loop look for that indicator, and if that indicator is set, then go to some logic somewhere that will continue that explosion process. And if we put this in the main game loop and we structure it correctly, everything else will keep moving. All the missiles will fire. The enemy ships will keep moving. The player shot, if the player has a shot active, that'll keep moving. So that is one approach, and sometimes that's right. Another approach is we could jump to a completely different loop. Similar to what we did with the pause loop, where we just jump to a whole different loop and did it that way. And then, unless we put that code in there too, the enemies and all that would just freeze while the player exploded. I'm pretty sure I've seen games that do it this way. I can't think of any off the top of my head, but that's another route we could take here. And I'm kind of inclined to do that because that really is the simpler approach. So I think here's what we're going to do. I think we're going to clear. If the player gets hit, we're going to clear all the enemy missiles and the player missile. We'll just clear everything. And then we'll jump to this death loop. And the death loop will process the player explosion, whatever that ends up being. And then once that's complete, well, we'll figure out what to do at that point. I'm not sure what we're going to do there. But I think that might be the way to go. So the first thing we need to do then is we're going to want to remove all the missiles. I want to remove all the missiles. So now I think we have something for this. Well, we have a race missile. That's fine. I don't remember exactly how we call that, but let's look at how we call a race missile. So what is in FF that we're passing there? Let's see. Oh, it's the enemy Y position. And then, okay, we have the erase mask. And the Y. That's right. That's how we did it. Now, I didn't do it here, and I probably should have. But one thing I like to do with subroutines in general is I like to put a comment up here explaining what the inputs are and what the outputs are, because you have a tendency to forget these things. It's not like C, where the function signature kind of documents it in a way, because it lists the arguments and the return type, and you give the parameters meaningful names. None of that really exists in assembly. So I do like to always comment the beginning of my subroutines with a description of what it's doing, what the inputs are, and what the outputs are. Some people go a lot further with this and have a whole list of what memory locations get touched, what registers get changed, and all that kind of stuff. I don't go to those lengths. Hey, you do your thing, whatever that is. And I kind of wish I had done that here, but I didn't. So it looks like erase missile. So we pass in the accumulator the erasure mask, and in the Y register we pass the Y position. Oh, that's right, because the missiles are all 1300, so there's no address involved. Okay, so that's simple enough. So here's what we're going to do then. So I don't remember exactly how we stored the Y position, because I haven't looked at this code in a week, and I've been working on a lot of other things. So here's what we're going to do. We're going to erase all 4 missiles on player hit. So the player's missile, the erasure mask, is going to be FC. And the player missile Y position is going to be player shot Y. So that should erase the player missile. Then the next player's erasure mask is going to be F3. And if you don't understand why these will erase the missiles, diagram them out. Write these out in binary, and you'll get why they're doing what they're doing. Now, enemy shot. That's right, I made these into an array. So enemy 1 shot Y. Now I could do this in a loop. I'm not going to. Enemy 1 shot Y. No, I'm not going to do it. Okay, I had a thought there that would have been fun, and if I wasn't writing this for the purpose of instructing, I probably would have done it just because I think it would have been fun. All right, the next erasure mask is going to be CF. Then we load Y. Enemy 2 shot Y. Boy, this cat really wants something. I already fed you, sweetie. And finally, The last erasure mask is going to be 3F. And then load Y, enemy 3, shot Y. Now, something that I have mentioned occasionally is debuggers. So I highly recommend learning how to use a debugger. That's a very important thing. Now, if you do have a debugger, it's going to be part of the emulator you're using. And so I don't know what emulator people are going to use for this. So I can't really give general instructions on how to use a debugger, but they all follow the same basic principles. And it'd be very helpful to step through some of this code and watch exactly what it's doing, particularly with these masks and stuff, so you can see exactly why I'm doing the things that I'm doing. Now, if I did this correctly, as soon as the player gets shot, all the missiles should disappear. So let's go ahead and see if that's the case. And I actually need to do a little bit more work here, but let's see what happens. I want to... Okay. Well, they all disappear except the player's was already gone. Let's reset it and try again. I want to get hit while the player's missile's in flight, so I can confirm that that one gets destroyed too. Okay, good. So we erased all the missiles. Now, after erasing the missiles, we're going to want to disable all of them, I reckon. So we're going to set the... we did that by putting FF into the Y location. So... we'll load A, FF, store it to player shot Y, enemy 1 shot Y, enemy 2 shot Y, and enemy 3 shot Y. Okay, so that will reset the missiles logically, which is important, because I want to resume. So my plan here is to jump to this death loop, where we're going to do some kind of cool explosion animation. I say it's cool, but it's really not going to be cool. And then once that explosion animation is finished, we're going to jump back to the game loop, and it's going to pick up right where I left off. So then the enemies will resume their movement and fire new missiles. So that'll be cool. We'll do that. All right, so now instead of jump star here, we're going to jump to what we're going to call death loop. So now, of course, we need to actually have a death loop. And I'm going to leave this top pane open because we're going to need to create some new variables here. So we'll put, I like to have pause loop being like the last loop. So we'll put death loop in here. Now, if we wanted to, we could allow pausing during death. This is something that I try to incorporate pausing everywhere that I think is reasonable. But yeah, I'm not really sure if that's something I'm going to bother with here. But you could. I mean, you could incorporate pause into this loop. Although what we should do, actually, is at the very least, we probably want to clear the last key pressed every frame. Because if we don't do that, if someone pushes pause during the explosion, it's not going to do anything right away. So that would get recorded as the last key pressed. And then as soon as we jump back to the game loop, it's going to look at that and say, oh, you want to pause the game. So if you hit pause during the explosion, as soon as the game starts up, it's going to pause. But on the other hand, maybe we do want that. I mean, that doesn't sound that bad. It's an interesting side effect of the way this is written. You know, like, hey, you blow up, push pause, and so it'll pause before the game starts again. You know, let's do that. I'm going to leave that in there. It's completely unintentional, but, you know, I don't really care. But, hey, as a challenge to anyone who's watching, hey, go download this code. I've been regularly posting this code to AtariAge.com, the Atari 5200 forums. Hey, go download this code. Try to incorporate a proper pause in the death loop. Why not? Okay, so I'm actually not going to jump to death loop. I'm going to put a loop label in here, and I'll show you why in a moment. And we're going to jump to that, because we're going to have a bit of preamble here. In fact, you know what? I'm going to take all this stuff out of here. All this missile erasure. I'm going to put that here. This is going to be the preamble to death. So we're going to take this, I'm going to put it here. This is just going to be like preamble to the death loop, erasing all these missiles. So I'm going to move it here. Now, okay. Something we could do here is we could change this from a BEQ that skips over the jump to the death loop. Since this is so close, we could change this to a branch on not equal to death loop and get rid of this jump and this label. The problem with that is that, I don't know if I've mentioned this before, this is a 6502 thing, is that branch statements have a range. So the actual argument to a branch instruction is an offset. It's an 8-bit offset. So a branch can only jump up to 127 bytes forward or 128 bytes backwards. And I don't like using branches. I mean, it depends on the code. But I anticipate we're going to put some more logic in here. So if I did make this a branch straight to here, it would work now. But as I put more stuff in here, we'd eventually reach a point where it would be too far. And then I would have to just go back to what I have right now. So I usually, I prefer to use branches for within subroutine jumps and save jump for a major go somewhere else type jump, at least until I get to the point where I'm optimizing for space, because this would be smaller, but I can't guarantee that this branch will still be valid. So I'm going to leave it as a jump for now, but that is something you can do. All right. So, oh, and by the way, if a branch becomes too far, the assembler will complain about it, or at least DASM will. So what you get from DASM is a branch out of range, and it tells you, hey, this branch is too far. And then you end up having to go back and rewrite the logic to turn into a jump. You basically end up doing this exact pattern where you branch over a jump that goes to where you wanted to go, to whatever location is now out of range. But yeah, that's a 6502 thing, not a 5200 or anything like that. That's just a property of the chip. All right, so here we go. Now, I should mention, since I'm in, so a jump is an absolute address. So a jump is followed by a 2-byte address, like the full address. So jumps can go anywhere. There's no limitations on that. But branch instructions can only go a certain distance forward or back in terms of byte count, which makes them faster, presumably. Or, well, it makes them smaller, certainly. I'm not sure if it's faster because it would have to... it has to take the value, the argument to the branch instruction and add it to the program counter. I mean, it might actually be faster just to read a whole instruction, but it is 1 byte smaller, and, you know, size is important sometimes. All right, anyway, so the death loop clears the missiles, and then we're going to set up the, a little explosion animation. But not yet. So here's what we're going to do instead. Let's, initially, let's just set up a timer. So we're going to create a death timer. We'll store this at address 27. So we will initialize the death timer. We'll give the death timer a value of 60. So this is an NTSC console, so it runs at 60 frames a second. So if we do 60 frames, it'll be 1 second. So what we're going to do is, every time through the loop, we're going to decrement the death timer. If it doesn't equal 0, we're going to jump back to loop. Otherwise, we're going to jump to game loop and restart the game. Now, that makes the immediately following jump useless, but this is really temporary code. I just want to demonstrate how this this separate death loop is going to work. So what we should see now is, once the player gets shot, it's going to stop for a second. The missiles will all get erased, and we'll just pause for a second, and then the game will start up again, is what we should see. So let's go ahead and build it and see if that's what we get. Okay, so let's get shot. Okay. Oh, I know what's wrong. Oh, that's silly. Yeah, I forgot something. So this is a good thing. This is a very good thing. I always like running into mistakes like this because you're going to run into stuff you forget about. And it's good to see them. So let me play that again one more time. Boom. Okay, so look at what's happening here. The game is frozen. It's kind of like going into slow motion at this point. What do you think has happened here? If you followed along up to this point, test yourself. Do you understand what's going on? I know exactly what's happening. I recognized it right away, but do you get it? Do you know what's happening? All right, I'll spoil it. Here's what's going on. When we jumped here, look what we didn't do. We didn't clear the collision registers, which means that that bit that indicates, those bits that indicate that the player was shot, they're still in the collision registers. So we jumped to this loop, we waited 1 second, then jumped back to the game, and then the game logic came down and got to this collision check, and these registers still have the same values in them. We never cleared them. So it immediately says, oh, player's dead, and jumps back into here. So if the player has died, one of the things we need to do is to write to hit clear, because otherwise that game is just going to keep seeing the player's dead over and over again. So let's just go ahead and stick a write to hit clear in here. And that should fix it. I thought that was a fun little glitch. That was cool. Okay, so now we get shot, pauses a second, and then it picks right back up. And look at that, there's our bullet. You know, I want to get this with the bullet in flight, just to make sure it's resetting properly. Yeah, I always like to check as many permutations as I can. If I could time this. Okay, I just barely fired it. Okay, let me get it higher up. Okay, it disappeared. And there it goes. All right, so it looks like we're good. Looks pretty good. Okay, so we have our death cycle now, right? We don't have an animation or anything, but you get hit, boom. It pauses for a second, then it resumes. So we have this death cycle. That's cool. That's great. So it's functionally there. Let's just work on the visuals a little bit. And I don't want to get too fancy with this explosion because that's not really the point of this. You know, I'm not much of an artist myself, and you know, I don't want to get crazy with this, but you know, we'll put something in there, you know, just to spice it up. So here's the player sprite. How tall is it? I think I have it up. Do I have it up here as a constant? And we'll just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So he's 16 tall with the buffer zeros on the top and bottom, just in case we do vertical motion, which at this point I'm thinking we might not do. So what we're going to do then is do some kind of an explosion. I don't know how we're going to do this, but we'll put something together. So let's start by just copying what we have already. So I'm going to make a new label. I'm going to call this Player Explode 1. Okay, so here is the player. And I think what I might do is switch the player over to double wide mode, like after 1 frame. I think that would be cool. So with the player sprite, we only used 7 of the pixels. So we've got this column on the right that's completely unused, and that's going to be convenient here. So I think what I'm going to do is I'm going to split them right down the middle, kind of. I mean, I can't do it perfectly down the middle because it's an odd number of pixels, but we're going to go just to the left of the nose, and we're just going to put in a column of zeros all the way down. And then we'll go ahead and get rid of these zeros on the end. Okay. So now this is going to split the player 1 pixel. That'll be the first thing we do. And then after that frame, I'm going to go ahead and copy this here. We'll do like 3 frames. Just to do a simple animation and show how you might do something like this. So there's Player Explode 2. So Player Explode 2, what are we going to do? I think after Player Explode 1, I'm going to transition the player to wide. And we'll just like start carving stuff out of the middle here. So, actually, no, we'll take stuff off the edge. Let's take all this stuff off the edge. I have a really vague concept how this is going to look, and I'm probably totally wrong about it. My visualizations of this kind of stuff tend to not work too well. Okay, so we got this garbage animation. This is gonna be so bad. This is probably gonna look stupid, but who cares? Then we'll make player explode 3. So what we're gonna do now is I'm gonna put another 0 row in here to like force it apart even more. So we'll put another 0 in the middle. And actually 2 zeros in the middle. So I'll do it again. Then I'm going to erase the zeros on each side. And if I'm visualizing this right, and I'm probably not, this might look interesting. Or it might look stupid, but I don't really care. It's just going to look like what it looks like. So now there are a lot of ways that you can process an animation. I mean, there's like a lot of different ways you can do it. And it just depends on... it just depends on how your code is structured. But the basic concept that you're going to have in any animation is you have a timer, and when that timer expires, you go to the next frame. Now, how you store those frames and stuff like that, that's a much more complicated topic. Like this, for example, is a one-off animation, right? There's no looping. It's just going to blow up, and we're done. But you could do a looping animation, you know, where it, like, for example, you had a character running or something, you'd have a looping animation. So you need to come up with some sort of data structure that describes how this animation is supposed to process. We're just gonna kind of brute force this thing because I don't really care. But we'll see what happens here. So what's the bare minimum we need here for an animation? Well, we need a timer, and we got it here. We're gonna use death timer. And we need to know which animation frame we're currently on. So I'm going to create another variable we'll call death frame. We'll store that address 28. So now we have death timer and death frame. So here's what we're going to do. Here in the death loop, do I have an erase player thing? I must, right? Because I wrote it for the enemies. Or did I call it like player erase? What did I call it? Okay. Never mind. Kill enemy, draw missile, erase missile, pause loop. Draw player. Okay, I do have a draw player. I'm in the wrong pane. It's not where I want to be. Let's draw player, draw enemy. Okay, I guess I don't have a general erase missile. But you know what? We're going to kind of brute force this, you know, just to do it. Okay, so we're going to start with the... where's the death loop? Kill enemy, process enemy, draw missile, erase missile, pause loop, death loop. Okay. So we're going to make the initial death timer one frame. So we're going to give this one frame after you get hit, and then the animation's going to kick in. So, you know, we're gonna get fancy. All right, so I want to write 0 to death frame. So we're gonna do load x number 1 death timer, then dex, and then store that to death frame. So when you're storing consecutive numbers like this to set things up, it is a little, at least smaller probably faster to use either X or Y because you can increment and decrement those. So since I wanted to store 1 and 0, just store, I could have done the other order too. You started with 0 and then incremented and stored that, but that's where we're at. Okay. So what we're going to do now is we're going to decrement death timer. If it's not equal to 0, we're going to go to loop. Now, if it does equal 0, then we need to advance to the next step in this death animation. So the way we're going to do that is we're going to look at the current frame. So we're going to load the... Well, first, let's reset the timer. So the first frame is going to happen after one... the first step of this animation is going to happen after one frame. But after that, we're going to take a little bit longer. Let's go with... I'm going to go with a full second initially, just so we can see each frame happen and make sure that everything's working fine. But we're going to make that a much smaller value once we know it's all working. So we're going to store that to death timer. So reset the timer. And then we're going to load the frame, the death frame. No, actually, we're not going to load the death frame. We're going to increment death frame and then load it. No, we'll just load it. Okay. So now we're going to take action based on what frame we're currently on. So we'll branch on equal to 0. So if we're equal to 0, this is the first frame. This is our very first toggle. So we're going to branch to frame 1 because we're just starting. If it equals 1, we're going to branch to frame 2. How many frames did we have? 3? If it equals 2, we're going to branch to frame 3. If it doesn't equal any of those things, then the animation is done. And I think at this point, we're going to jump back to the game loop. Okay, so here we go. So we're going to have frame 1, frame 2, frame 3. Well, actually, you know what? I'm going to stick it in here just so I don't forget. At this point, we have to redraw the player because we're about to start again. And we need to make sure that we put the player back on the screen because we just obliterated him. Well, actually, no. You know what? Frame 3 is going to be completely erasing the player. So we're actually going to have a frame 4. Then we'll redraw the player and restart the process. So we're going to have a frame 4. All right. So now I want to mention again, this is kind of a brute force method for doing this. In a proper, more developed system, you'd have some kind of an animation framework that would know the sequence and would just advance to the next one in the sequence. But we're not. We're going to brute force this baby. So in the end, what we're going to do here is we're going to take one of those images and copy it over the player. So, but let's see, if this is frame 1, so this is the initial split. So what we're going to do here is we're going to load. All right, we're going to do a little bit of common code here. So we're going to load the frame that we want to draw. So that's player explode 1. And we're going to take the low byte of player explode 1. And we're going to store that in FE. Then we're take the high byte of player explode 1. And we're store that in FF. And then we're going to jump to update player, which I haven't written yet. So here it is. So the idea here is that each frame is going to set up the frame that's going to be drawn, and then update player is going to draw it. Now this is with the exception of the last one. So the last one's just going to erase the player completely. But the other frames are all going to look like this. So in fact, I'm just going to copy and paste this. And I don't generally like copy and pasting code because I feel like if I made a mistake, I mean, now I've got like 5 mistakes. I didn't get the last line. But we are going to do a little bit more there, actually. In fact, let me grab this. Paste it here for frame 3. All right. Let me make sure this just builds. Oh, I updated the player. Oh, now I screwed up. I love you, Vim, but I swear, sometimes you just decide to do weird things. Okay. So, before we go into frame 2, I wanted to make the player bigger. I wanted to go to double wide mode. So we're going to, at this point, we're going to load a 1 and store it into size P0. So that'll blow up the player. Now, frame 4 is just going to erase the player. Yeah, so let's start off by resetting the size then at this point. So we load 0, put it in size P0. So we go back to normal size. And then we're just going to erase the player. So we'll do kind of a manual draw here. Now, you could set up a blank player image and just go and fall back into update player. But I'm just going to do another little... I'm just going to blank it. So we're going to load player height. Do I have a draw player function? I don't know if I do or not. Okay. Or load player height. Go into a loop here. Actually, no. Load X player height. No, that's fine. We know where the player's Y position is because it's hard coded. I don't remember what it is though. I should probably make it into a constant since I've decided I'm not going to do vertical motion on the player. Player Y, B8. All right. You know what? I'm going to continue being bad and not make it a constant. All right. So it's B8. So we're going to take player height and we're just going to store to. So I know 14B8 is the top of the player, so we index by Y. Decrement, branch on positive to loop. So that I think that's going to erase the player. I'm a little worried about those offset, those little padding bytes. I don't remember if those are relevant or not. So we'll find out. All right, so that is the... oh yeah, once we're done, we jump back to Deathloop. Okay, so up here where this is where we're gonna end. I'm gonna redraw the player. I'm gonna put a jump star in here, just so once the animation is finished, it'll pause so we can consider what we've just seen. So this is the general update player routine where we have the frame we want to draw in FEFF. So I think I'm actually gonna do it this way. We're going to load Y. We're going to load player height -2 because I need to get around those padding buffers, those padding bytes. And I think player height is currently based on those padding bytes. Do I even have a player height? I don't. All right. Huh. I thought I had a player height. Do I not have a player height? Didn't I just build it with that in there? Label mismatch. Oh, I've got 2 loop variables. Or 2 loop labels. Oh, I don't have a player height. All right. So, well, we'll load 16. Because I know the actual player is 16, but I think I need to start 1 up because of that padding byte. So we'll do this then. So we're going to do except 15, because off by 1. Off by 1 will get you every time. All right, so this is the update loop. We're going to take the frame that is pointed to by FEFF and copy it to the player. So we're going to load dereference FE index by Y, store it to 14B9, Y, decrement Y, branch on positive to update loop. And then jump back to death loop. So, all right, let's see if this works. I have a feeling it's not going to, but we'll see what happens here. So if we did this correctly, it's going to be a very slow animation. Oh, you know, I forgot about, there's something else I need to do with respect to the size change I forgot about, but let's watch what happens first. Boom. Okay. Nothing happens. Oh, you know what? I never incremented the frame number, did I? I was going to, and I just didn't. All right, there's probably a better way to do this, but I'm just going to force it. Well, right here before we jump back, we'll increment the frame. And right here before we jump back, we'll increment the frame. There probably was a smarter, shorter way to pull that off, but I don't feel like spending too long trying to optimize this code. Okay, gotta get shot. Gotta get shot. Okay, 1. Okay, it's still not working. Why is it still not working? All right, well, it's time for some debugging. Let's see what's going on here. So, frame 1, this part is clearly working because we're seeing that player explode 1 frame. Then we jump to update player. Oh, it's because I jumped to death loop. That's the wrong place because death loop just resets all this stuff. So I need to jump not to death loop, but to dot loop because death loop's the preamble. You know, sometimes I change this to like start death loop or something, which probably would have been a better name in this case, but oh well. Okay, so there's going to be something broken here. There we go. 1. Ooh, big fat and split and dead. Okay. So when you move the sprite from single to double width, it still stays at the same X position. So it kind of squirts out to the side. So I need to offset the sprite position when we go to that wide frame, the fat frame. And then I need to put it back at the end. So where is the player? The player is the player X. So right here, well, here's where we go back to size P0. So I'm actually going to put it before that change. Now, the reason I'm putting it before that change is because we're using this 0 down here in the erase loop. So I'm going to do this first, then we have the 0, which we use here. So that's that. Now here, okay, so when you go to size P0, when you go to double width, you go from 8 pixels wide to 16 pixels wide. So we need to move to the left 4 pixels. So here's what we do then. We load player X, set the carry bit, subtract 4, and write that to hpos P0. All right, let's see what that looks like. Okay, see, now it's still centered. That's a really crummy explosion animation, but I don't really care. I just want to do something. Now, so now that we have that, let's put, we got to regenerate the player here. Now notice that when we altered the player position, we didn't alter the value stored at player X. So the original player X is still there. We just changed the value at hpos P0 and then reset it back here. So player X is still good. And I think it is a draw player, right? Do I have a draw player? Yes, I have draw player subroutine, which knows exactly how to do everything. So all I have to do is call draw player down here in death loop before we go back to the action, and we'll be cool. Okay, so you know what? I think I'm going to put in. No, you know, let's do it this way first. I think I'm going to change this, but we'll do this first. So right here, we're going to JSR to draw player. So then we put the player back on the screen after we've exploded the poor little guy. Let's see what happens here. I think I'm going to make a slight adjustment to this, but let's look at it first. Boom. Boom. Down. Whoa, he's way up there. Okay. So that was not expected. Why did he end up way up there? Oh, did I have to... Is draw player expecting some sort of like input or something? Yeah, I think draw player is expecting something in the Y register, expecting B8. Yeah, it is. Okay, that's just kind of a historical artifact from when we were actually moving the player vertically. I don't really feel like fixing it, so I'm just going to keep it in there. Okay, we'll try that again. Boom. Boom. Gone. Back. Okay. Look at that. Pick right up. Hit again. Boom. Boom. Gone. Back. Okay. So I'm going to do a couple little adjustments to this thing. So the first thing I want to do is obviously shorten the animation time. So what we're going to do is this. I'm actually going to move where we do this death timer. Maybe. Well, first of all, let's just make it faster. Let's see how this looks at 10. What I want to do is I want the very last one to be longer. I want there to be like a bigger delay for the very last frame, so you get some... Yeah, see, that's too fast. Like, I mean, the explosion animation's fine. That speed is kind of okay, but you appear again too quickly, I think. So I think what we're going to do then is... if we wind up down here in the update loop, this is where I'm going to put the timer. I'm going to put it at 5. Now the very last loop here, where we erase the player, then we're going to put it at 60. I want a full second there. So let's see how this looks. Boom. And we're back. You know what? That's cool. I'm fine with that. I thought about having another delay like after you appear again, but you know what? I don't care. This is a cheesy game. If you want to play with it and adjust it and make that change, you know, that's on you. Hold on, I gotta check some real quick. Okay, so now we have a player that can die, and we got a cheesy little animation. We got a death loop, and you know, game picks back up. That's cool and all. It's very cool. I can't believe how awful this animation is, but you know what? I don't really care. Okay, so we have well, we've accomplished something, haven't we? Look at that. And we're just short of an hour in. All right, great. So what to do for the next hour? So what do we have now, you know, in terms of, you know, of a game? Because I think we're getting close to the end of this game, you know, just this game project. There's something else I would like to do. In fact, we might even finish this tonight, which would be a good thing, because that would allow me to jump into the next thing after a week break. But, so we have enemies. You can shoot them. You get score for them. That's great and all. and you get shot and you die. Now we could put in a live system here. I reserved that bottom row to put in lives, so you could put in lives, right? And in this death loop, you could, you know, decrement the lives, and maybe we could put a life counter down there, and when we're out of lives, you have a game over. Could do that, but I don't think I'm going to, at least not right away. The last thing there's one more thing I want to touch on, because now I've kind of got it in my head that I want to end this particular game project tonight, and maybe in 2 weeks start another one that illustrates some different antic modes and does some different things. But the last thing I kind of want to touch on is sound. Now, sound is a very difficult subject. I'm hoping I can get this done inside of an hour. Now, one thing I want to make very clear is that to get good sound out of this system, you really need to know what you're doing. I don't know what I'm doing. But we're going to make a few beeps and bloops. Now, Pokey is a... I need to actually... Okay, so at the moment I'm actually suppressing sound from the emulator, but I need to... I'm adjusting the sound balance right now. I don't know how loud this is going to be. Now, whenever I start this emulator up, I get this audible pop. Yeah. So, we're going to put some real sound in here. So let's look at Pokey. So in addition to doing input, Pokey is also the sound chip. So when it comes to audio, here's what you need to know about Pokey. There are 9 Pokey registers that you need to be concerned about from an audio perspective. The first one is this one here, Odd Control. This is the master audio control. This register is something you write to, and it has a bunch of global settings for Pokey. Now, there's a bunch of different frequency timings, all kinds of crazy stuff you can do with this chip that I honestly don't understand. I'm not a sound guy. My last 2 games, I've had someone graciously step in and do the sound for me, someone who's very, very good with this chip and actually knows what's going on here. But Odd Control is the master configuration for all the sound. It sets various properties that apply to all the sound in the chip. Now, beyond Odd Control, Pokey has 4 sound channels. And so it can play 4 independent sounds. So each of those 4 sound channels has 2 registers associated with it, a control register and a frequency register. So Odd C1 is audio control for channel 1, and then we have Odd C2, which is the same for channel 2 and 3 and 4. And then Odd F1 is the frequency for channel 1 and 2 and 3 and 4. Now, Odd Control, each of these audio control registers includes a volume setting and then certain other settings that control the way that channel behaves, which again is way more complicated than I understand. So I'm not going to go into crazy details on those. The volume, however, is something we can talk about because that's pretty obvious. It's volume. Now, I believe the volume is a 3-bit value, I think. Or is it 4-bit? It might be 4. It might be the lower 4-bit. So you have 16 volume levels, I believe. I'm going to need to pull up some documentation on this, which you're not going to see on stream. I'm going to pull up a web browser and check this out because I don't remember specifically how this worked. I actually hadn't planned to get into sound tonight, but I think that's the direction I'm going in, so I'm a little unprepared for this. All right, so I am going to, oddly enough, the place I usually go for documentation on these chips is actually Wikipedia. So that's where I'm going. Although my web browser seems to be misbehaving right now, and I don't know why. What are you doing, web browser? Why is there so much disk access right now? I apologize for the delay here if you're watching this on YouTube, but this is how we go. All right, so Pokey. All right, so if we're going to do stuff with Pokey, the very first thing we need to do is to set up the master audio control. So we're just going to go ahead and Go up here to our sort of our startup code here, where we just get everything set. We're going to go ahead and put something in here. So let's see what we got here. Odd control. So I'm looking at the documentation right now, and yeah, there's all kinds of crazy stuff in here that I do not understand. You need to be a sound guy to get this. But I'm going to go ahead and write a 1 to odd control. So the least significant bit of odd control contains the chip's sound frequency. Its divider rate, as it's called. So 1 gets you a 15 kilohertz divider, 0 gets you 64 kilohertz. So I think 0 gets you higher valued tones, and I want the lower valued tones here just because I think I do. Now, audio channel, the odd C, the individual channel controls, I was right. The lower 4 bits are the volume. The upper 4 bits are controlled noise and some other stuff. So I think what we're going to do here is we're going to start just by generating some simple tones. So we're going to put, we'll go max volume to start with. So 0F is going to get you maximum volume without touching any of the other settings. So initially we're just going to play with channel 0. Or channel 1. Now, I'm kind of afraid that this is going to create a noise right away. So you might want to cover your ears. I'm going to see what this does now. Oh, look at that. We got some noise. Okay, that is not what I expected to hear. Got some static. I don't know why it's doing that. Oh, it might be because we initialized the chip, so we got a 0 in there. All right, if I write a 1 to audio frequency, 1. What do we get? We get an error because I can't type right. More noise. Okay, this is actually surprising me. I wasn't expecting this noise. I was just expecting tones. All right, I must have configured something incorrectly here. Oh, I'm in like... Okay, I'm in like kind of a PAL mode or something right now. Okay, so to master audio control, we're going to go ahead and write 6.1. So I think we're in sort of a PAL mode right now or something. Okay, it's still noise, but that's different noise. That's not what I'm expecting. I was expecting tones. But hey, let's work with this. So, again, I want to emphasize, Pokey is a complicated beast. This is not... this is not an area of my expertise. I just wanted to get something in here, though. But I am curious as to what I'm doing wrong here. I feel like I've got something wrong with odd control. All right, so the way the audio frequency registers work is they control the pitch that's being played on each channel. So the way it works is that can't remember how this works. Okay, so I think that smaller values in the frequency counter get you higher tones. That doesn't seem right, so we are just running a 1 there. Let's try putting... Let's try putting FF and odd F1 and see what we get. We're just going to do some experimentation here. It's been a while since I've done Pokey, since, like I said, someone has done sound for me the last couple games. Okay, I do not understand why these are the tones we're getting. This doesn't make any sense to me at all. Let's see. I'm going to go back and reference some older code of mine. So this was the last game I did my own sound on. And it wasn't good. But it's there. Let's see. Character select? This will work. What do I use for odd C here? Odd control. I just use 1. Okay. Now, I'm going to be looking at some weird stuff here, because I had kind of my own sound format that I built for this. Man, it's been so long since I've seen this code. I barely remember it. Okay, I seem to use E3 a lot for an odd C value. I have no idea why I do that, but I do. And it looks like I was just using 1 for odd control, and then E3 for odd C. So with that in mind, let's put kind of a middle value in here. We'll put 80 or 80 in the frequency, and let's just hear what we get. Interesting. Not what I was expecting. Why am I just not getting tones out of this? All right, let's see what FF gets me. Huh, weird. Yeah, I'm not super familiar with Pokey, if it's not obvious. I don't do this work a lot. But you know what? We're going to put together some sound effects, even if they're terrible ones. You know, just to have them in there. There we go. That's more like what I was expecting. Okay. So I guess it's just a matter of getting the right values. So one thing that might be obvious about Pokey from the get-go right here is that when you put a tone to play into Pokey, it keeps playing it until you stop. Like, you can't, there is no, like, you have to write a whole sound engine that controls how long these sounds play for. You know, is the sound going to decay over time? You get a volume shift. And these can get pretty fancy. Like I said, the fellow who was nice enough to do the sound for my last 2 games for me gave me his sound engine. It's a pretty complicated piece of work. I would not have come up with it on my own, certainly. But what we're going to do here is we're going to see what we can do. So this E3 is interesting. So the volume here is only 3. It's not a very high volume. Let's try turning the volume up to, I don't know, A. That's better. Whoops. Lost track of the window here. Okay, so all right, so we got the basics here. We just made a beep out of Pokey, and that's wonderful and all. But let's go ahead and try to actually do some sound. So Now, Pokey gives you 4 channels to use. And in a real sound engine, you need to balance which channels you use for which sound effects, because you can only play 4 sounds at once. So you need to have some system for managing that. You can't just keep layering in sound effects. And how you do that is it's going to vary a lot. It depends on your sound engine, how it's structured, and how you want to work with it. I think we're going to avoid getting too fancy with this because, again, I'm not a Pokey expert. So I think we're just going to play all of our sound effects on channel 1. Just to do it. So the basic thing you need for any sound engine, even the most primitive one, is you need to track how long you're going to play a sound on a channel until you shut it off. So I think what we're going to do is we're going to have a little thing here. We're going to have, let's see, sound duration. $29. And I want to store sound control. So this is the control value. So because I have an idea here. Let's see how this goes. So the way we're going to play a sound is by putting a tone into Pokey with a duration and a volume. So I don't know why this cat keeps yelling at me. She usually likes to lay on my shoulder. She'll sit up there for 15, 20 minutes at a time. She often climbs up there on her own, but she doesn't seem to want to be up there right now. Sometimes that's what she wants. Anyway, so what we're going to do is we're going to use these variables to track the sound. So basically we're going to decrement sound duration, and once it reaches 0, we're going to shut the sound off. So I mentioned one time, a long time ago, that the place you want to put your sound processing is in the game vertical blank, because sound involves timing, a lot of timing, and vertical blank interrupt is the only place where you can actually get accurate timing. So we're going to put the sound processing in here. We'll put it after the keypad cooldown. Actually, no. If you want your sound to really be correct, you want to make sure you have consistent processing of it. So if you look at this here, now this is probably getting a little too crazy, but I'm just going to point this out. If you put it after this no cooldown label, then the exact timing that the sound processing gets run is going to vary. It depends on whether or not this branch gets taken. So I like to put the sound processing before any decision making. In fact, I actually like it to be the very first thing in game VBlank. Like, don't screw around, just go do your sound right now. So that's where we're going to put it. So what we're going to do is we're going to load sound duration. Now, if sound duration is 0, that means there's no sound playing, so we don't need to do anything. We'll branch then to sound done. But if sound duration is greater than 0, that means that there is a sound currently playing and we need to deal with it. So what we're going to do is this. Actually, you know what? I'm going to do this a little bit differently. I just had a new idea. All right, we're going to do this a little bit differently. So here's what I'm going to do. We're going to use sound duration as the length of time that sound is going to stay at its maximum volume. And then once it expires, we're going to make the volume fall off. So, no, okay, I think I know how we're going to do this. We're going to do sound duration. Okay, we're going to load sound duration. If it equals 0, sound is done. Okay, we're done. I changed my mind about how this is going to work. We're going to do this, but I just thought of a better way to do it. So if sound duration is 0, there's no sound currently playing. We don't care. We're done. Otherwise, we're going to decrement sound duration. Now, if it doesn't yet equal 0, then we're going to go to sound done. All right. If sound duration equals 0 at this point, then we need to drop the volume. So we're going to, now if we drop the volume once a frame, it's going to drop off too quickly. You won't be able to hear it at all. So I'm going to put 10 in sound duration at this point. So we're gonna drop it off a little bit at a time. Now the reason I have sound control is that we're going to load sound control, decrement it. So this is going to drop the volume by 1 tick. And then we're going to store that to odd control. Actually, we're not do this yet. Okay. So we're going to take the current sound control, drop the volume by 1 tick, store, not odd control, odd C1. Then we're going to see if the volume is currently down to 0. So if we mask off the uppermost bits, because those are not volume bits, and we get 0, then we've just dropped the volume to 0. At this point, we're done. We're done processing this sound. Otherwise, we need to continue processing. This, we're going to put this 10 in here into sound duration. Oh wait, this is okay. I did this wrong. I need to dec sound control in memory, and then load it. Okay, so I think this is going to work. Now we need to so what our sound effects are going to be then is going to be a frequency and a duration. And a volume. So we're going to have an odd C value, an odd F value, and a duration. That's going to be our sound effect. So let's go ahead and make just a fire sound effect, a shoot sound effect. Let's see what we can do here. All right, I wanted to see these values. So let's start by just making one for the player. So the player is at trig. So the player shooting code is going to be near trig 0 because that's the button. So here's where we start the player shot. So before we get crazy with this, let's go ahead and start the sound effect. So we're going to go ahead and we're going to write, we'll use this value we have right now, which is EA, to odd control 1. And they're also going to write that to sound control, that value that we're tracking, so we can drop it. Because this is, well, this isn't a write-only register, but odd control 1 is something different if you read it. I think it's one of the pot values, yeah. So we have to have our own local copy of that data. So we'll write odd control 1 there to sound control. And now we need a frequency. We'll use, I don't know, 20. And we'll put that in frequency. And then we need to say, okay, how long do we want the sound to play for? It's going to be pretty quick. We'll do 20 frames. And we'll write that to sound duration. All right, so that's going to be our basic, how do you play a sound? You have a control value, a frequency, and a duration. And then we'll run this. We'll see how this sounds. Probably sounds terrible, but it's a start. Oh, that's kind of neat, actually. It'll last way too long. It kind of fades out as I drop the volume. Now, there was this really high whine when I first started it up. I think it's because I was writing this here. We need to get rid of that. Okay, so that sound lasts way too long, and it's kind of dumb. It's not a very sensible sound, but... Whoops. We have a sound effect now. It's not a good sound effect, but it is a sound effect. And again, Pokey is full of sound options. I mean, there's noise generators and all kinds of crazy stuff. So I'm just throwing sounds out and seeing what sticks. But let's try a different frequency. We'll go for a lower frequency. Okay, again, this is a terrible sound, but, you know, it's something. Why are you yelling at me, sweetie? I didn't forget to feed you, no matter how many times you try to tell me I did. Okay, so we have a basic sound effect now. It's a terrible sound effect, but it's a sound effect. I do think it lasts too long. It lasts for, geez. Okay, so the base value is 1/3 of a second, and then it decays over a very long time. So I think we'll speed up the decay rate, I think. So instead of decaying every 10 frames, let's make it every 5. We'll speed that up. I do like that volume fall off. That's pretty cool. Okay, so we have this really terrible sound effect now, and that's cool. But let's put some more terrible sound effects in. So I'm going to keep this as a reference for what we're doing here. So what about when the player missiles fire? When does that happen? I think we have a process enemy subroutine here somewhere. No, not that pane. This one. Okay. So somewhere in here we fire the missile. Move missile. Handle missile. Alright, this is where we start the missile. So this is where we're going to put the our sound effect. This is going to be just a cacophony of sound. Why am I not finding this? There we go. All right. So we're going to take this whole concept again. And we're going to put it here where the enemies fire their missiles. We're going to try some different values, though. We'll keep the volume thing. We're going to put a different frequency in here. Like, how about C0? Let's see how this comes out. It might be garbage. Who knows? It's going to be a lot, though. Because they're firing almost constantly. Yeah, it's just the sound effects are all fighting with each other, so I'll go into the same channel. So let's change the duration of this sound effect, make it much faster. And I think we'll do the same with the player shot. Let's make it a lot shorter. Interesting. All right, not sure how much further I want to push this sound stuff because this is kind of, I said, this is getting into territory I'm just not very authoritative on. But I think you kind of get the idea here is that you have to set up Pokey, you have to set up the master audio control, and then for each channel you have a frequency and a control register, and you work those two together to get them to produce the sounds. And then you need some sort of regular frame-by-frame audio processing where you adjust the sound based on some system that you put together. I mean, you have to put together your own system here, or in my case, have someone who's kind enough to help out with audio in your projects and gives you a very nice sound engine. And you can check that sound engine out. If you go to my website at phasercat.com, you can find downloads for all of my Atari games. And if you download one of the two most recent ones, which would be IntelliDiscs and Robin Banks at the time of this recording, you will find the sound engine I'm talking about, and you will see, how much goes into that. But I do want to emphasize that I did not write that sound engine, so don't blame me for any code you find in there. But it works fantastically. The sound on those two games is great. Like, really can't complain about anything about it. And I'm very grateful to the people who have helped me, put that together. So I don't really want to waste too much more time banging on with this sound because it's going to be terrible no matter what we do. But I've demonstrated how Pokey works to some extent. But yeah, Pokey is a massive undertaking to get really good with. And it takes a lot of experience and knowledge of how sound works and how sound chips work to do good stuff with it. But let's take a look. So here's what we got, right? We got this. So here's our game. This is our game here. We got 3 ships. You can shoot the ships and they move around. Oh, something I wanted to do is sprite multiplexing. But I don't really know if that's something I want to do anymore. I think I might do an example of sprite multiplexing, but it's not going to be a useful one. Because I do want to show this before I go here. So what is sprite multiplexing? So sprite multiplexing is when you reposition sprites mid-screen draw to allow you to have more objects on the screen. So the 5200 gives you 4 player objects and 4 missile objects. And in this game, we're using all 8 of those objects. But you can get more objects by sprite multiplexing. And I think what we'll do here is we're going to try putting something at the bottom of the screen. We're going to try multiplexing player 0, I think. So what we're going to do here is we're going to put something... Oh, you know what? Draw player. This is a good example. So draw player allows you to put in a Y position. So here we go. Let's do that. Okay. So we're going to do this. We're going to do load Y. Now, B8 or something was where the player is currently located vertically. So let's just pick another value that's further down. We'll try D0. Let's see how this looks. Okay, there we go. Almost what I wanted. I think I'm going to kill the sound on the thing because we've heard these enough. All right, so you see here, we now have a second copy of the player. Because remember, a player is really like a vertical column of sorts. So I've just drawn the player again at a lower address. Well, a higher address, but lower on the screen. And you notice when they blow up, actually, you see that bottom player get wide briefly because they're getting hit. You know what? Player 0 is not right for this. I'm going to do this with player 1, actually. Because player 0 is going to be screwed up because of the size change. So we'll do draw enemy here. Let's see. So Y must be what? What is Y? Okay, I gotta remember how to use draw enemy. All right, so Y is the enemy Y position. Oh, and the page is there. Okay, so we're going to multiplex player 1, not player 0. So here's how we're going to do this. We're going to draw the enemy again. Lower down. So we'll load Y. Oh, wait, what did I have there before? We'll keep that same Y. But we're going to... So we're going to draw them on page 15, which is the page for player 1. So if I did this right, we should see another copy of player 1 down there at the bottom. There it is. Okay. So see, there's another player 1 down there. Because I'm drawing player 1 up here and then down here. If you see it, up there, down here. Drawing at 2 locations. So we're not really sprite multiplexing yet because that's the same sprite, right? It's just draw in a couple different places. So where you get fancy with this, and I'm actually going to I'm going to move him down a little bit. Let's move him down about 4 pixels. I want to get him underneath the moon, down into the text area there. How much farther do I got to go? All right, maybe like 3 or 4 pixels. See if D8 gets him into the right place. Good enough. Okay, so that's where we're going to put him. All right, so there's our sprite bouncing around down there. But it's following the horizontal position of the player above. So that isn't really multiplexing. It's the same sprite. It's just moving around. So here's what we're going to do. We're going down here to these displayless interrupts we made. Now remember these displayless interrupts. So we had this interrupt down here on the bottom that changed the playfield colors so they go back to the text area at the bottom. But we're going to add something else here. We're going to load let's say 20. And we're going to store this value in horizontal position player 1. Now this is not going to work correctly, but watch what this does. It's too low. I forgot. That's off screen. Okay. Okay, so I was right. It did not work correctly, but not for the reasons I had anticipated. Let's go with 40 here. All right. So look down there. There's another copy of player 1 down there. And you'll notice some weird stuff happens when the player gets blown up. And I know exactly why that's happening. But let's start by moving that lower player 1 over a little bit further. Now let's talk about what's going on here. So it looks like we've got another object on the bottom there that's moving around pretty much independently of that one up there. So what's happening is that in our vertical blank interrupt down at the bottom there, we're changing the position of the player 1 sprite. So when we get down to that lower area, its horizontal position has moved. Now the normal game logic updates the X position of all the enemy ships every single frame. So when we come back from drawing the screen and run the game logic, that X position is being reset to where the enemy is supposed to be up top. But you notice when the player gets destroyed, that stops happening and the thing moves over. Because if you remember, in that death loop, we weren't running the enemy logic. So that change we're making in the interrupt is staying for the next frame until the game logic starts running again and starts going again. So what we need to do then is we need to fix up the death loop to make sure we put player 1 into the right position. So every time through this loop, we're going to reset player 1's position. Actually, you know what? This isn't the right place to do this. I'm going to put it in the vertical blank interrupt. Actually, what am I looking for? I'm looking for enemy 1X, right? Okay. So in the vertical blank interrupt, after we finish drawing the screen and processing the sound, among all this other like per frame stuff, I'm going to reset player 1's position. What am I doing? Load A, enemy 1X, store hpos p1. So that should fix that jumpy problem we were having there. See, now he stays where he's got to go. But what I'm trying to demonstrate here is that by organizing your screen carefully and with strategic use of interrupts, you can reuse the sprites at at different locations on the screen. And you can change a lot of stuff in these interrupts. You can change sprite position, sprite size, sprite color. We can make this dude a different color. So let's do that. Let's see how that works out. So we'll change his color. What color will we make it? Let's make it, we'll just do white because I happen to know the color code for that. So we're going to write the color white to color player missile 1. Now, of course, all the usual stuff about displayless interrupts needs to be honored here, right? Because you make sure you W-sync properly and all that. Now, in this case, I actually have one scan line to spare before I see that. So you can plan things to give yourself time to do this kind of stuff. But you see here, we've changed the color of player 1 down there at the bottom. So you can do a lot of crazy stuff with these sprites and the displayless interrupts by changing things as you go down the screen. And again, this is a very simple example, but we could take a whole bunch of these player objects, reposition them on the bottom, and use them for different purposes. Like, I don't know, maybe we want to make some meters or something on like a shield gauge or something. Well, you could take these player objects and repurpose them as a shield gauge down at the bottom of the screen. And the cool part about the way this is laid out is there's all this space in the middle, right? Like once you get below that yellow ship, there's all kinds of room down there to reposition and recolor and everything, reconfigure the player objects. I'm doing it at the last possible moment, but you could put an interrupt somewhere in the middle of the screen where you could do all this sprite repositioning for the status area at the bottom. And the best part is, since the sprites aren't being drawn anywhere near that, you don't need to worry about W-sync because there's nothing to see. There's nothing on the screen that you'll mess up by changing stuff in the middle there. So this is for me, one of the most interesting parts about developing for the 5200 is that the capabilities of the system can drive the design of your game, at least in terms of the screen layout and where you put things. Because you need to think about about vertical space. Because almost any game of any real complexity is going to do sprite multiplexing. There's going to be a whole lot that you're going to do. But you have to plan things out. You have to organize your screen in a way that allows you to do the multiplexing you need to do. Now you notice here that we changed the color of the player 1 sprite at the bottom to white, but it's still green up top. And the reason for that is the same reason that the playfield colors reset to their proper values when we get up top earlier. And that's because we didn't write to the shadow registers. We wrote directly to the player missile 1 register on GTIA. Now, the shadow registers, which is where we initially set the player colors, up here somewhere. Here. No. Where? Somewhere. Here we go. So this is the shadow register for the player missile 1 color, where we put C5, which is this green color. So, and I've mentioned this before, but I'll state it again. The vertical blank interrupt in the BIOS takes the values in these shadow registers and puts them back into the color registers on GTIA. So effectively, the vertical blank interrupt is restoring the colors back to what they were at the top of the screen. So you don't need to worry about changing the color of player 1 back to green because that's in the shadow register. And the vertical blank interrupt will do that for us. So you always want to think about the color shadows on page 0 as the colors you want to be set at the beginning of the screen draw. And then any changes you make mid-screen draw with interrupts, those will be undone for you by the vertical blank interrupt and it'll reset back to the beginning. Now, unfortunately, the only thing it resets are the colors. So any other stuff involving the player, you need to reset yourself, like the horizontal position, the size, priority. You can change priorities mid-screen. All that other stuff, you need to repair yourself, like we did in the vertical blank with the position. But yeah, so that's how sprite multiplexing works. Now, in this case, I'm using the sprite for something inactive. It's not down at the bottom of the screen that are doing nothing. But you can get crazy with this. We could have all kinds of enemies. We could have enemies all up and down the screen if we just keep multiplexing the sprites all the way down. Now, one problem you do run into with sprite multiplexing is that it tends to make hardware collision very difficult to use because the hardware collision doesn't know the difference. The hardwired collision just says, this missile collided with player 1. Now, if you multiplex player 1 and you're using player 1 in 3 different places on the screen, the hardware register alone, the collision register alone won't tell you which one you hit. You'll need to do some more sophisticated testing in software to figure out what actually got shot. But if you keep them separated enough, you can look at, for example, the position of the player 1 missile, right? And you can say, okay, well, if the player 1 missile is in this range, it must have hit that one, or something like that. And other times you won't be able to tell, and you'll have to do your collision entirely in software. So there are drawbacks to sprite multiplexing, especially with regards to the hardware collision registers, because they become much less accurate. Because you have several player 1 sprites wandering around, and it just doesn't know the difference. Player 1 is player 1 as far as GT is concerned. But I think that's probably where I'm going to close this little sample game project, is with that brief little example of sprite multiplexing. And again, we're taking next week off. I have a Veterans Day commitment. But the following week, I think we're going to come back and we're going to start a kind of a new project. There is another sample project I'd like to do because I want to show off some other aspects of Antic. Some of the other graphics modes and some of the stuff you can do. And that's going to require a whole new project. So in 2 weeks, we'll be back with a whole new project, and we'll go and look into some other stuff. I think I'm going to cut this stream off for now. It's been close to 2 hours. It's been about an hour 30, about an hour and a half, which is, that's good enough for me. So if you follow along so far, I do want to thank you for tuning in. If you're watching this on YouTube, of course, thank you for watching this on YouTube. It's been a lot of fun going through this and teaching things and, putting together this little simple sample game. I will be posting this code to the AtariAge.com forums in the 5200 section where I have a thread running for this series. So if you want to get this code, play around with it, maybe goof around with the sound effects, add some more stuff, whatever, feel free to grab it. You want to keep running with this and turn it into a full-fledged game of your own? Hey, go for it. No skin off my back. That's why I'm doing this. So the code will be posted for anyone who wants to play around with it. And I guess that's where we're going to sign off for now. So I will see you again in 2 weeks where we will start with a whole new project. And I think it's going to be a fun one. So enjoy your evening and good night for now. And we'll see you in 2 weeks.